Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at the State Hygienic Laboratory at the University of Iowa. Why is chloramine used for water treatment? Why not just use chlorine or monochloramine or something else? Or why treat it? So disinfection is an essential step in the water treatment process because it can destroy microorganisms that may cause diseases in humans. Think bacteria, viruses, pathogens, things like E. coli, legionnaires, other problems. Public water systems utilize various disinfection practices, some of which may potentially lead to undesired harmful chemical byproducts. Following the regulations for disinfection treatments and byproducts is an important measure to ensure water is safe to drink. So we have the use of chloramine. It's a chemically formed by the reaction of chlorine and ammonia. Chloramination is the actual term of the chemical process and may be used as a primary or secondary disinfection for drinking water. According to the United States Environmental Protection Agency, more than 1 in 5 Americans use drinking water treated with chloramines, and chlorine is still considered the most effective disinfectant in water treatment plants to disinfect water for distribution and consumption of drinking water. Also, ammonia is either present in some concentration in the source of water or is added for purposes of disinfection as chloramine. Chloramine is often used as a secondary disinfectant and is increasingly used based on its effectiveness as a disinfectant and its longer residence time in distribution systems. Increased regulation of disinfectant byproducts, the chemicals formed from the use of chloramine like THM or HAA5s, has caused water utilities to seek more effective approaches to disinfection. So first they use chlorine, then they use chloramine, they can also use monochloramine, but there's still byproducts and issues, so it's always a good idea for them to update to make it more and more efficient and more safe. Such as chloramination is a primary reason for the increase of chloramination treatment in recent years, because it can significantly reduce the formation of regulated disinfection byproducts, or DBPs, such as HAA5 and THMs. So there's some advantages to using it. Monochloramine has been used in the water treatment for more than 90 years, and even though chlorine is more efficient to eliminate microorganisms, the benefits of chloramine are less production of regulated DBPs than chlorine, cost, and longer residence time in the distribution system, resulting in better overall disinfection. Since the enactment of disinfectant stage 1 and 2 rules by the EPA, the cost of water treatment facilities has increased due to require to reduce DBPS, the byproducts, and chloramination has identified as the most effective approach to reduce regulated DBPs in drinking water. Some source waters, particularly have a residual amount of free ammonia, which reduces the amount of ammonia to be added and also reduces the overall cost. Now there's a disadvantage. The disadvantage is the complexity of balancing water chemistry to ensure the maximum amount of monochloramine while minimizing dichloramine or trichloramine. Monochloramine is the most active disinfectant, and dichloramine and tri lead to taste and odor issues, and in addition, the potential nitrification in the distribution system cause nitrate and nitrate levels to exceed maximum containment levels, or MCLs, and therefore become a potential public health hazard. And nitrification occurs when free ammonia is oxidizing by nitrifying bacteria in a distribution system to form nitrate, and another major disadvantage using it is the formation of highly toxic ionated DBPs when iodide is present in source waters. Now there's the environmental health effects as well. Normal levels of chloramine found in drinking water go from 0 to 4 milligrams per liter and are considered safe. The maximum containment level and higher levels are not associated with significant health outcomes, but there needs to be careful monitoring chlorine, chloramine, and the formation of DBPs. And DBPs are the most toxic. It depends how the mixtures affects the overall toxicity, but the effects from nitrogenous DBPs form from chloramination of wastewater effects and have been observed in a complex mixture of DBPs. So it's difficult to determine which compounds exhibit toxic effects, but they can. And since chloramine is effective, it is used in a lot of disinfectant when it comes to water treatment. But it still has its issues, and it still has its drawbacks and its environmental problems. That's why it's always a good idea to have your water periodically tested.